Alrighty. So let's take a look at these. How do we do this? What do we need to do? I'm trying to add some fractions together. What's up? Huh? Oh, I don't know. First word always kind of like a straggling. Like, you get here, but it takes a minute. So think about if we had 1/5 plus 1/3. What would we need to have in order for them to be able to be added together? Say it again. Common denominator. What's our common, or what is the denominator going to be? 15. It needs to be the product of both pieces. So our least common denominator is going to be 15. How do I get them to both have a denominator of 15? What do I need to multiply the 1/5 by to make it have a denominator of 15? I was going to say, I can't multiply by 1/3, but I can multiply by 1, even if I make it look weird. 3/3 is the same thing as 1, right? Huh? Is it? Oh, it's not showing up. Ooh, fun. Where the heck is it putting that? Nope, still not doing it.
They decided not to work today.
They are deciding not to work together right now. And what are they doing? Because yes, I was writing, but it's not.
Are they fighting again?
They are just a little bit. I don't know why though. Where do you think you're broadcasting? You think you're going to the right place. We'll try one more time and then have to restart the software. Oh, there we go. Yeah, I had to threaten to restart the software, didn't I? Argumentative little piece of work. There we go. Now I'm writing on the screen. Woohoo! So to get our 1/5 to be with a denominator 15, I can multiply it by 3/3 or 1 that just looks weird. So for my 1/3, we have to do something real similar. We need to multiply it by a funny looking 1 that's going to get us to that common denominator. So our funny looking 1 is going to be 5/5. So we do both of these fractions to be able to get them to have that common denominator. So my 3/3 times 1/5, here we're getting our multiply across. 3 times 1 is 3. 3 times 5 is 15. So 1/5 is the same as 3/15. Then we're adding that to this 1/3 times 5/5, which is going to give us 1 times 5, which is 5, over 3 times 5, which is 15. So when we add these together, now that we have a common denominator of 15, I can do that. We can do our 3 plus 5. What is 3 plus 5? 8. Out of 15. And then we look and see, does 8/15 simplify? No. So we are good and we are done with that one.
For some reason, I felt like it.
I was going to say 8 is really only divisible by 2 as far as prime numbers go, and 15 is only divisible by 3 and 5. So other than 1, they don't have any factors in common.
Forgot my pencil.
I was going to say, I have a few back there. Not tons, but I do have a few. And if all that's left is IKEA pencils, let me know and I can get you a regular size pencil. All right, so very similar vibe on the next one. Yay, 3/4 plus 1/2. So it might be a little bit easier to do mental mathy. What is our common denominator going to be?
2.
8.
I would say 8 is a common denominator. 2, we would wind up with decimals in our numerator, and that's unpleasant.
And 4.
So 4 would be the least common denominator. 8 will work. You would just have a simplify step at the end. If we get the least common denominator, there is the minimal risk of simplification at the end. I do not guarantee it, but minimal. You do not have to use the least common denominator. Using a common denominator is totally fine. So it would totally work. We can simplify fractions. But if we want to go for the least amount of work, finding that least common denominator will be helpful. And so that's going to be 4. So my 3/4, I don't actually have to do anything to. It already has our denominator of 4. What do I need to do to the 1/2? Multiply by 2. But I can't just multiply by 2. 2 over 2. We're multiplying by a funny looking 1. Our 1s are going to look really weird today. Just warning you. Because this then gives us 2/4. And that's a little easier to picture in our head mentally, that 1/2 is the exact same thing as 2/4. That's what we're doing here. So when we add these pieces together, what do we get? What's our final sum going to be? Bless you. What is 3/4 plus 2/4?
5/4.
5/4. Does it simplify?
To a mixed number, yeah.
I mean, yeah, you could do 1 1/4 or 1.25, but 5/4 is as simple as it goes fraction-wise. And then our last one, 3/7 and 7/3. Does it change what we do? The fact that they look so similar? We still need to get them to a common denominator. What is our common denominator going to be?
21.
Mm-hmm.
But wouldn't that just add all of the numbers 21?
Let's look. Our least common denominator is going to be 21. So what do I need to multiply my 3/7 by?
Wait, no, it wouldn't. Brain? Oh my god.
It is 7:25 in the morning. Be nice to your brain.
We multiply by 3.
Mm-hmm. So it's going to be by 3 over 3, because we can't multiply by 3, because we do not have an equal sign to do the same on both sides. We just have fractions. So we can multiply by 1. It's just a funny looking 1. So my 7/3, what do we need to multiply that by?
7 over 7.
7 over 7. So that's going to give us fractions of 9/21. 9 over 21. Plus 49 over 21. So what's our final answer on this one? It's a way to find our least common denominator, or to find a common denominator, is to multiply them together. So like 7 times 3 gives us that least common denominator. And on the first one, 3 times 5 gives us that common denominator 15. Multiplying the two denominators together will give you a common denominator. But on things like this, we're just going to have to kind of think it and say what they have in common. Because you could start with 8 and then say, is there anything smaller? Correct. So we get our 58 over 21. I wonder what we're doing with our rational functions today.
We're adding.
Oh my gosh. Yes, we're going to be adding our rational functions today. Okay, which is going to be very, very similar. We're going to need to get things to a common denominator so that we can add pieces together. So we're going to be, it's page 7 in the note packet. Oh, that is not the one I want. There we go. So we're going to look at page 7 in the notes packet. And what this is here is this is just kind of a walkthrough on what we just did, where if I have two fractions with different denominators, I'm going to take the products of those denominators. I can straight up multiply by the denominator of the other one over the other and just simplify at the end. That lets us add these pieces together. It will also let us subtract these pieces from each other. Once the denominators are the same, I can put them in the same fraction. So just like with number fractions like we had in the bell work, rational expressions can only be added and subtracted if they have the same denominator. So our first one is set up quite lovely for us. I just want us to see it. So if we're asked to add x plus 5y over 24y plus x plus 2y over 24y, they already have a common denominator. So I wanted us to see that adding together part when it's a little bit lettery before we started having to make our own. So we already have a common denominator. So we're good to go in that zone. Let's see, I'll put it down there. So we have a common denominator. Check. So what that means is I can use the fact that they have that same denominator to smush them together. They're going to go over the 24y, and we're going to have our x plus 5y plus our x plus 2y. What do we get when we combine those pieces together? We need to combine our like terms. 2 x's. Yep, that's an x. And 7 y's over 24 y. So these are going to still look like rational expressions when we're done. We're not getting to an x equals or a y equals. We're just smushing them together.
So we're not doing the thing where if there's a y in the denominator, there can't be a y in the numerator.
If it was a like multiplying problem where we're trying to simplify, we could. If we're trying to simplify this up here, since we have addition, we would need to try and factor it. If I had a y I could factor out, we could then simplify. But since I can't take a y out of 2x, this is essentially a factoring thing where we can't pull anybody out.
Okay.
So if we can simplify, we're going to want to try. But it's not going to be often that we can if we find our least common denominator. So let's look at the next one. Got 7a over 4b. What's up? Oh, page 7. Sorry. Put that up here too. Sorry, these page numbers are like where we get them in the textbook. But we don't really use that, so not super helpful.
I still haven't taken out my textbook from last semester.
Yeah. We don't need to. I was like, that's why I give you guys like worksheets and stuff, because
No, I mean it's still in my book bag.
dude. All right. So let's look at this one. This is our first one. We're going to have to make our own common denominator here. What we're looking for is either our least common multiple or the smallest thing that has both of these pieces as factors. So look at the numbers. What is our least common multiple of 4 and 10?
2.
That's a factor. Go the other way. We need a bigger number that could be divided by 10 and by 4.
20.
20 can be divided by 10. 20 can be divided by 4. So 10 and 4 would have a least common denominator of 20. And then we also have that b in there, so our common denominator is going to be 20b. That's what we want to get these to. So if I want to be able to have my denominator be 20b, what do I need to multiply 4b by?
5.
Which is 5, right? Because it already has the b. It's got 4. To get to 20, we multiply by 5. But I can't just multiply him by 5. I can multiply him by a funny looking 1. What about for the
It already has B, no B.
we don't need to put another b in there, because if I put a b over here, it would be 20b squared. I don't want 20b squared, I just want 20b.
20b squared.
What about 10? What do we need to multiply this one by? 2. What other piece does it need to have?
2b.
B. So this is going to be an even weirder looking one because it's 2b over 2b. If you do not spot this, you can absolutely do this as 4b and 4b, where we multiply it by the denominator of the other side. Totally fine. Multiply this one by 10 over 10. You're just going to have to simplify at the end. So then let's do those two little multiplications here. My 5 times 7a gives us a 35a. And my 5 times 4b gives us a 20b. Then we're going to multiply my 4c squared times 2b. So 4 times 2 gives me 8. And you can either write it as c squared b or bc squared. I tend to do that because I default to alphabetical order. But it's not wrong to do it as 8c squared b. Totally fine. And then we're going to have our denominator of 10 times 2, which is 20 times b. So now we have that common denominator. Squish this up. Ooh.
Squish.
What can we do with that? Add them together. So when we add them together, we only write our denominator once. So it's going to be 20b. And we're going to have our 35a plus 8bc squared, or c squared b. Can I combine those together?
No.
Nope. Are there any common factors I can take out between every piece that's up here?
No.
No.
Sadly.
So that means there's no simplifying we need to do, which means that's our answer. This guy right here. Questions on this one?
I am puzzled.
On the next one?
Mm-hmm.
Well, let's take a peek-see at it. So we've got 7/3 plus 8 over 3 times x plus 2.
The greatest common factor is 3.
Correct. They have a greatest common factor of 3, but we're not looking for a greatest common factor. We're looking for our common denominator. So what pieces exist in denominators? We have a 3, and we have an x plus 2. This has a 3, this has a 3, and an x plus 2. So this guy already has both pieces. What piece is this one missing? The x plus 2. So I would really like to have an x plus 2 in the denominator over here. But I can't just multiply by x plus 2. I have to multiply by a funny looking 1. So this left fraction is missing this x plus 2. So this is the piece it needs to get. And we can only multiply by funny looking ones. So when we do that, what we're going to have is we're going to have our x plus 2 times 7. I'm going to write it like that for a second. With our 3 times x plus 2 in the denominator. Oop. This side already has it. Now they have that exact same denominator. That's what we were hoping to get there. So I can combine these together. What else are we going to need to do to be able to add these pieces together? What do I need to do with my pink chunk over here? My x plus 2 times 7.
Add 8.
Yep. I was going to say, but can I just like combine them together?
Yeah.
Plus 8. What do I need to do before I can do any actual adding? Because what would I be adding 8 to? We're going to distribute. Multiply this thing out. What's up? Okay. Just slowing down. So let's distribute that out. If you notice it here, you can do that here.
Are we also going to distribute on y?
We are not. We're going to leave our denominators in factored form whenever we have it. Just because that's pretty much how we use it. The numerators we will multiply out so that we can see if we can simplify properly, but denominators we will keep in factored form. So we have our 3 times x plus 2 in the denominator. We get 7x plus 14 on the top, plus 8. What is 7x plus 14 plus 8 going to simplify to?
My brain can't think. 7x plus 22.
7x plus 22. We can combine the numbers together, but there's not much else we can do. There's not anything we could factor out of this numerator. I don't have any GCFs. I don't have any quadratics, nothing I need to do to factor it properly. So this is our fully simplified form. There we go. So the denominator is an icky part, and that's kind of the we have to figure it out part. It's okay, we're gonna talk through it. Breathe, there is more. Because sometimes we don't get problems that are, oh, that is not the thing I meant, there we go. Sometimes we don't get problems given to us already in factored form. Sometimes we have to factor it ourselves. So let's take a look at this. Getting rid of this because we don't need this information. So let's think about this. First thing we're going to want to do is factor that. I don't want to have to multiply both sides by both pieces. So I wonder if any of these pieces already exist over here. So let's factor anything that has an exponent on it. So we're going to factor this guy. Our x squared plus 2x plus 1. So when we factor that, that's our a times c. Our 1 times 1 is 1. Our b is 2. Do we know a pair of numbers that's going to multiply to make 1 and add to make 2? 1 and 1. So since our a term is 1, we can write this as x plus 1 times x plus 1 using our shortcut. It has a numerator of 1. We've got an x over here. And I've got our x plus 1 over here. And I'm going to put parentheses around it because it looks like a dang on factor. So now that we see it like this, say it a little bit louder. Mm-hmm. Yep, because this one has 2 of them. This one only has 1. So I got to multiply this guy by what it's missing. So put it in factored form so we can make sure we have all the pieces here. So I need to multiply this guy by another copy of x plus 1. But I can't just multiply randomly by x plus 1. I have to multiply by a weird looking 1. So it's going to be x plus 1 over. Thank you. There we go. Our x plus 1 over our x plus 1. So we have to multiply by a funny looking 1. Once we do that, they have a common denominator. So let's get that bit written down. You can absolutely do that. Once we notice that and they have their common denominator, you can put it as x plus 1 squared. 100% okay. Our numerator here is going to be our 1 plus, let's do this multiplication. My x times x plus 1. Well, that's going to give us x squared plus 1x. And then we have our plus 1 over there. So it's,
technically factor that, right?
let's see.
Because it's just jumbled up.
Let's unjumble it and see if we can do any more simplifying. So if we put it biggest to smallest in terms of exponents, we have our x squared, then our x, then our positive 1. Is that something we can factor?
Just be x plus 1 and x plus 1. Wouldn't it?
That's what we had up here. Is there a pair of numbers that multiplies to be 1 and adds to be 1?
No.
No. So this one will not factor, but it's a good idea to check. Oh my gosh, this iPad is so tired. So that is our fully simplified answer here. There we go. Oh, I got my yellow hair back. So this is where we go. So they're not always going to look more simplified when we're done. Sometimes they're going to look weirder. And that's okay. Let's look at the next one. And we'll see about that. So we have 4 over x plus 1 plus 2 over x plus 3. Think of both of these as already been factored. These are both factors. So what is our common denominator going to be? What pieces do we have that exist in here?
X. And then
Think of our factors as a single chunk. So we're going to have our x plus 1 and our x plus 3. It needs to get both pieces. Whatever factors exist need to exist in our eventual denominator. So this is very much like in the bell work when we had the fifths and the halves, like 1/5 and 1/2. So separate pieces, they each need to get one. So if this already has the x plus 1, I need to multiply this by the piece it's missing. It's missing our x plus 3. But I can't just multiply by x plus 3 because I want to. I can multiply by a funky looking 1 though, x plus 3. So what am I going to multiply this one by? X plus 1. Over x plus 1. We have to multiply it by 1 because we cannot change the expression. If I had an equal sign, I could do the same thing on both sides, but I don't have that. I don't have equal signs here. So we have to multiply by 1s. So once we do that, these are going to have that same denominator. We're going to have our x plus 3 times x plus 1. And on this side, we have our 4 times x plus 3. And we're going to add that to this guy. Our x plus 3 times x plus 1. And our numerator is our 2 times x plus 1. So when we start working towards combining these together, since they have that same denominator, we can do that with our x plus 3. What's up? Oh, sorry.
You're right on.
There's a lot of x's. I got excited. Bless you. All right, so what can I do to this bit? What do we need to do with this blue part here? Distribute. So before I can really add the blue part and the pink part together, I need to do this distribution. My 4x plus my 4 times 3. So my 4 times x is 4x. 4 times 3 is 12. We need to do the same thing with our pink side. I'm just going to get a dark pink. So we're going to add that to, because we're adding our fractions here, our 2 times x, which is 2x, and 2 times 1, which is 2. So we get
6
mhm,
x plus 14.
6x plus 14 for our x plus 3 times x plus 1.
They have a greatest common factor of 2.
They do have a greatest common factor of 2. Let's see if that makes it so we can simplify anything. So it's an excellent idea to double check that. It is going to be incredibly rare for us to actually be able to simplify something again at the end, like with a factor crossing out. Like writing those problems is really hard because it's so incredibly rare. But it does occasionally happen, so it's a good idea to check. And the fact that we notice these both are divisible by 2, so I could write this as 3x plus 7. Does that give us anything we can simplify?
No.
No. Is it still a good idea to do it? Yes. Would I take this as an answer? Absolutely. Would I prefer this as an answer? 100%. So I will take both, but this one's better because there are occasionally times when we can simplify it again. It's, again, not super common, but it does happen. So just so we're aware. So this one's better. It's supposed to have 2 different colors there, and it's not. It is in such a mood today. So this one's better, but I'll take it on this one. Okay. So we will deal with the subtracting tomorrow. I was like, you can absolutely do it 100%. It's the exact same thing. We just have 5 minutes left. And instead of hopping into the subtraction, we're going to, save them for tomorrow. The only thing that's different is when we combine them together for our subtraction, like here, put parentheses so that you can distribute your minus sign. That's the only difference when it comes to the subtraction bits. So it's in the combining together. We're going to do some of those tomorrow.
Can I get a pass for
Yep. So the operations homework is going to be due on Friday because we didn't actually do any subtraction today. So it'll be due on Friday, but we'll talk through some questions tomorrow if you've got them because we have a skills check coming up on Friday. So once we get through our examples tomorrow, we'll be able to see if we have any questions on